Hello everyone, this is the 10th video of the series for AP Computer Science Principles. We're going to be talking about if statements, else if statements, and else statements in this video. Along with that, we'll be using conditional operators, and we'll get into some Boolean operators as well. Unless this first part gets too long, then we'll move it to a different video. I'm going to try and get out a few more videos soon. The next stuff we're going to be talking about will be functions. We'll get a video in on the debugger, since some of you are working on Project 1 already, which is great. Probably get a video on Project 1 as well. And what else? We'll have other things coming out as well. So, but this is on if statements. So, what are if statements? If statements are going to be these structures that will add type of it'll change our script from being so straightforward. Right now, our script is running one line at a time when we're using operators and variables. If statements are going to allow us to jump from one section to the next. So we call this branching logic, right? Either something will happen or it doesn't happen. So that means that certain lines can now be skipped based on the values of variables. So let's just jump right into it. First, let's make maybe a little definition. What is an if statement? An if statement is a, well, it really has two parts. It has two parts. One, we have the condition, which evaluates to true or false. And we also have the container. This is also called the scope, the block, or there's one other synonym. Okay. So if statements have a condition. Let's just go and make an if statement. It's gonna be easier if we just have something to work with. So let's make a variable, stick a number in it, and we'll make an if statement. If the value of box is greater than 0, and we'll put a colon at the end of this statement, then we can do something. Right now, we really only have one piece of functionality, which is using this print function. And we can print the value of box. And that's it. A few things to notice here. Our if word here, our if keyword, is lowercase. It's also orange. I'm going to write things to note. If is lowercase. We're going to notice that we use the conditional operators here. So these are the less than, greater than, less than or equal to, greater than or equal to, is equal to or not equal to symbols. We can use any of those to make a condition. Third thing to note, we end the line with a colon when using if statements. So a colon, you have to press the shift key that shares the key with the semicolon. And lastly, we use an indent, a tab key, or if you want to call it a tab character, in order to define the scope of the if statement. In Python, using tabs, or the tab key, which is above the caps lock key usually, is very important. If you do not tab correctly, you'll actually get an error. This isn't true in all languages, but for Python it is particularly important. So if we delete this tab here, then we'll actually see this little red error. It'll say indent inspected. Because we have a colon here, we have to have something that's inside the scope of this if statement. So what is the scope? We keep using this word, scope, container, box, and other words I can never remember, apparently. The scope is a section of code that belongs to a structure. So if our if statement here is a structure, we're going to say that anything after this that we do that is indented belongs to the if statement. So the way these work is if this condition is true, then we'll run all the code in the scope. If it's not true, if this is false, we're actually going to skip to line 21 here. So maybe we do something like add 2 to box, print box, and be done. So there's 2 possibilities here. If the value of box is greater than 0, we're going to print that value, which should be 5 at this point. We add 1 to it to make 6. Then when this container, when this scope finishes, when these 2 lines finish, we'll actually add 2. So we'll have 8, and then we'll print 8. So that's if this initial value is 5. If somehow 5 was not greater than 0, but let's just keep the value as 5, then we would actually skip both of these lines here, and we would just add 2. So we'd only print box once, and it would be 7. Or if we made it like -1, if this was -1 here, then we would skip these 2 lines, we would add 2 to get box as +1, and then print that. So let's see, make sure that actually happens. And we do see we print box first to get 5, we add 1, which is 6, we add 2 to get 8, and then we print it. So we're actually jumping around now. In older languages, this was an assembly command called a jump command, where you could actually jump to different addresses within your code, so that your computer would be actually able to not just go linearly. And we're doing the same thing here, except we don't really see addresses. I don't even know if in modern computing they actually use line numbers like this. I would think they would, but I can't say that for sure. And if we see -1, we'd expect to see just +1 here and only print box once, and we do see that. So this is an if statement. This condition here has to evaluate to true or false. So whatever the condition is, it must evaluate to true or false. So if you have something like this, box is if box, Python's actually going to let us run this, but for a weird reason. This also goes to older languages, but older languages would evaluate any value that's not 0 as true and any value that is 0 as false. So it's actually going to allow us to do this. So we should get, this should be true this time. So we would print -1, add 1, then add 2, and we get, so we'd be printing -1 and then we'd be printing 2 when we run this. So that's evaluated as true. If we set this to 0, this is actually going to be evaluated as false, so we should just print 2 when we run this. And there we go. So kind of weird, but like, let's say we have something that would break this. Let's see. Actually, I don't even know if they evaluate strings to 0, 1. I think they do, so this would just be true again since it's not 0. But can we put something in here that would break it? Probably. It's going to be hard though. What if we put a print statement in here? What if we did this? Well, what does this print statement return? Does this evaluate to a value? As it turns out, it actually does. Whenever you have a function like this, usually functions return a value or don't return a value. So in Python, when something doesn't return a value, it actually does return a value. It returns, so I think this is going to return none. But let's see. Python, what value does print return? Or we could just look up what value do void functions return. Yeah, so it returns none. So for none, if none, I think this is going to evaluate as false. I'm not sure though. I mean, it's not 0, but it's not 1 either, or a standard value at least. So if this counts as being true, then we should see this print 3. Otherwise, it's going to print 2. So it does count as true. Since it's not 0, since we get none here, it evaluates as true. Okay. I have one way to break it. If we don't put anything, it will have a problem with that. We do need some kind of expression. We need something here that evaluates to a single value. So those are our limits for a conditional expression. Let's move on to else if statements and else statements. So there's a few possibilities for making these structures. Possible, we're going to call these conditional structures. We could make an if statement with no else if or else, just like we did here. We could make an if statement with an else, which we'll do next. We can make an if statement with an else if. We can make an if statement with an else if and an else statement. And lastly, we can make an if statement with multiple else if statements. I guess there's one other option, and no else. Or we can make an if statement with multiple else if statements and an else. These are all the possibilities for if statements. So some things to notice: you always have to have an if. So you can't have one of these structures that starts with an else if, and you can't have a structure that only has an else. You can have an if and an else, you can have an if and an else if, and then you can have any combination of else ifs and elses, so long as you only have one else, a maximum of one else, or no elses. All right, let's look at some of these in action, because I know this is a little strange looking when we haven't used this before. First thing to note though, when we say elif here, this is just a shortcut for else if. In other languages, you might actually write out else if. In Python, they thought, you know what, we got a shortcut. Let's just call it elif instead of else if. So that's the first thing. And then there's the else statement. So let's make a if else statement. So we'll use box again. If box is greater than, let's see, right now this is false, so box is going to be 2. We'll say if box is greater than 1, we can print box. Else, we can do something else. We can say box plus equals 1, and then we print box. How about that? So what's going on here? The else statement you can think of as the default statement. This is what's going to happen by default if the if statement is not true. So when we run this code, and if this is false, then we don't run this line. So we can see this in action by running it. If we run this and we get box as being, if we print box and box is 2, then we know this was true, and we only run this. If it's not true, then we'll actually get box to be 3 and print box. But we can never do both of these scopes here. We can only do one. So let's run it. So we're now getting this box print, and then the second one here is what happened next. So that means we're hitting this if statement. So since 2 is greater than 1, we print box. But we did not run this code. Now if we change this, if we just let's set box equal to 0. All right, well now this is gonna be false, which means we are not gonna print box. We're gonna increase box to 1 and then print it. So we should see 1 printed. And there we go, we get 1 printed. So the else is the default for when all previous conditions are false. It's the only way we can run the scope of an else. All right, next, we've looked at the single if statement, we've looked at the if else statement. Let's make a few of these other possibilities. An if and an else if, number 3 all the way to number 6. Okay, so what we can also do, let's just set box to 3. And we do something like this. If box is greater than 2, we print value of box. Otherwise, if box is equal to 3, then we can do something different. We can, what would make sense to do here? Print the box as 3 exactly. Here we're printing a string, and there's no default statement. So there's 2 things going on here. One, we've actually created something that might be considered a logic error. If we are checking to see if box is equal to 3 in this else if statement, the idea would be that this if statement isn't going to be triggered if box is equal to 3, but it is, right? This is true when box is equal to 3. So we would print box and we would never reach this else if statement. So what this means is that as these conditions currently stand, this is an unreachable statement. There's no condition in which this will ever actually print. Now Python isn't going to pick this up. The compiler won't pick this up for us. But when we have something like this is an unreachable statement. If we switch this, well, now this is a reachable statement. We check if box is less than 2. It's not. It's false. So we skip this container, this scope here, and we jump to our next condition. So now we test our next condition. When we looked at the if-else statement, the else actually does not have a condition. So that's something important to remember. So maybe we'll make some notes here. Notes, or things to note. Else statements never have a condition. So we write them like else colon without anything else. You have to be careful with capitalization, so it is lowercase. The other thing here is we have to be careful with our conditions because it is possible to have conditions that can never be reached. They're unreachable statements. Sometimes Python will recognize this. For instance, if we say something like this, if true, and we say print box. Otherwise, we take box and add 1 to it. Well, now Python's going to recognize that this line is unreachable. It's going to put it in this yellow highlight and say this code is unreachable. And this is just a yellow error, which means it's just a warning. It's not going to break our program if we run this. So not an issue, but generally speaking, we want to fix these yellow errors if we can, just to organize our code better and to make things more clear. So both of these are unreachable. Well, this was unreachable. Now it is reachable. So in this if-else statement, there is possibilities where nothing is printed. So suppose that, let's change this text here to say the value of box is less than 2. If box was a value of 5, or really 2, either 2 or 4 or greater, nothing is going to be triggered here. The if statement won't be true. The else if statement won't be true. So we'd move on to the line after that. So that is possible when you don't have an else statement. So we run this and we see that we don't get any strings printed. The last thing that is printed is this line right here, where the value of box is 5 now. Okay, what else can we have? We can have the if, else if, and else. Like this right here, number 4. And we could also have multiple else if statements. So we're going to kind of just combine these into one last example. So let's make something with some context. Let's say we have a grade like an 85, and we say something like, if our grade is greater than 90, then we say you got an A. I guess it should be greater than or equal to. Else if your grade is greater than or equal to 80, you got a B. And we'll do the same thing for C. You got a C. And then we'll use an else. Oh, wait, there's D as well. Greater than 60, you got a D. Otherwise, you got an F. So we have 3 else if statements here, but anything lower than a 60 is just one default answer, right? It's just an F, if we're not talking about pluses and minuses here. So you can have as many else ifs as you want, and you can always have a default statement. And when we run this, we would expect we get this. So this is one useful tip when programming. Always check your code after you write a section of code, whether it's a structure or a few lines. You can always test it, see if you're actually getting what you'd expect to get. One thing you'll notice is that oftentimes your first time writing some code will produce an error that you didn't expect. And that's just the nature of learning this kind of thing for the first time. You're just going to make more mistakes at first. Yeah. All right. So those are different if, else if, and else statements. One thing we haven't talked about that we should include on this video is something called nested statements. So nested statements are when we have if statements inside the scope of if statements. And we'll also mention that this is also possible for our other if structures, such as if, else if, or if, else, if else, or whatever else. So what does this look like? Well, let's say we have a let's just take our code here. Let's just copy paste it. We'll have two versions. We'll give a little comment saying that this is version 2. And let's say we want to add our pluses and minuses, but we don't want to change the full structure here. Well, what we can do is inside this if statement, we can have another if statement that says something like this. If our grade is greater than or equal to 87, well, now we differentiate from just the A. Maybe we say that you now have an A plus. Wait, I should say 97. 97 plus 97 for an A plus. As a heads up, I don't think we do pluses or minuses anymore. It's just A, B, C, D, and so on, if you were wondering. So we would say you got an A plus. What other options are there? Else if our grade is greater than or equal to 93, well, this is a solid A. You got an A. And otherwise, we know it has to be at least an A minus because it's greater than 90. So by default, the last option is that it has to be an A minus. So we actually don't need this last statement anymore. We could just delete that. So since these are all indented, that means that if this first statement is true, we're going to run all 6 of these lines. And then each of these statements have their own scope. So if this statement is true, we would run this line. So that means that if our number was, let's say, 98, then this line would be true. So we're going to run this block of code. Then if we run this line, this is true. So we're going to run everything indented inside this if statement. And then once we print this, well, where do we go? Well, when we have an if else or if else if structure, we always only run one of the blocks. So once we run this, we're going to skip these second 2 blocks. We skip them, right? So we'd really go after this line here on line 85, but now this actually completes this big if block. So once we run this line, we skip the rest of these else if else blocks, and we're actually done. So in this big structure here, we are only running one of these if statements. Sorry, not if statements. We're only running one of these print statements. And we could do the same thing for, we could do the same thing for B. We just got to change our numbers and our strings here. So this would be 87, 83, and then we could do the same for D's. Or C's, and then also for D's. Okay. So our structure is getting, pretty big. You could have a very large if-else-if statement if you have a lot of differentiating to do for if you have a lot of data to work with. So when we run this, we see our, let's see, our first statement here is giving us a B for grade 85, and then for 98 we get an A plus. Let's change it to 72, so we'd expect a C minus, and we get a C minus. And we could do other tests as well. Just keep testing, make sure that we're getting what we expect. And it seems to be working for those tests. Okay, in the next video, we will talk about Boolean operators and how we can give our little conditional operators an upgrade.